In number 13, we're asked to graph the function f of x equals x minus 4 squared plus 1 with that domain restriction, x is greater than or equal to 4. And then it says find f inverse of x. So again, we've got that domain restriction in our function. So let's take a look at the graph of this function. And, oh yeah, I've already got it in there. So x minus 4 squared plus 1. Let's take a look at the graph. And if I were to graph the entire parabola would have, let's see, the vertex at 4, 1. 1, 2, 3, 4, 1, 2. So it looks something like that, quick and dirty sketch. So the original function without the domain restriction, okay, so this is the function with a domain from negative to positive infinity, the entire parabola. This function would fail the horizontal line test, which means its inverse would not be a function. Okay, so that's where the domain restriction comes in. That's where the domain restriction comes in. This parabola that's on my graphing calculator, if we just start at the vertex, 1, 2, 3, 4, 1, so there's the vertex, and we only graph the parabola for x greater than or equal to 4, so we only graph that area to the right, then if I apply the horizontal line test, it passes. That means the inverse of this domain restricted function, where the domain is from 4 to positive infinity, that means the inverse is a function. So typically with these domain restricted functions, we had the domain restriction to ensure that the inverse will be a function. So the domain restriction gives us a one-to-one starting function that will then produce an inverse that is also a function. All right, so let me just skip ahead because we're already talking about the graph of our original function. So I can see that it goes through 4, 1, that's the vertex. And then using the trace function, we have the ordered pair 5, 2, and 6, 5. So that's pretty good. Let's just go ahead and graph it using those 3 points. All right, so for my original function, f of x, we have the ordered pairs. I'll just write this little table over here for future use. So we've got 4, 1, 5, 2, and then 6, 5. Okay, so that's with the domain restriction. Now we're asked to find the inverse of the function. So first, let me write my function using the y equals notation. So y equals x minus 4 squared plus 1 for x greater than or equal to 4. And then I'm going to switch my x and y, and at that point, I'm writing an equation that represents my inverse. So x equals y minus 4 squared plus 1. And instead of x greater than or equal to 4, I'm going to switch that to y greater than or equal to 4. And I'll subtract 1 because now my goal is to solve for y. So now at this point, I have x minus 1 equals y minus 4 squared, or if I just switch those, I'm going to put my y on the left. So y minus 4 squared equals x minus 1, as long as y is greater than or equal to 4. And then to get closer to solving for y, I now want to take the square root of both sides, but remember that I've got my plus or minus. So this gives me y minus 4 equals plus or minus square root of x minus 1, as long as y is greater than or equal to 4. I'm just going to erase this little domain so it's not crowding me. Okay, so if y is greater than or equal to 4, then what do we know about this side of our equation? Y minus 4, if y is always greater than or equal to 4, then this side of the equation could be 0 or it could be positive, right? So if y is like 5 minus 4 is 1, positive 1. If y is greater than or equal to 4, the smallest that left side could be is 0, or it could be any positive number, right? It's not going to be negative, can't be negative. So if the left side can't be negative, that means the right side can't be negative either. So I can now rewrite this as y minus 4 equals the positive square root of, x minus 1, where y is greater than or equal to 4. But now that we've gotten rid of that negative square root of x minus 1, it's actually not important that we keep in the y greater than or equal to 4. Because that's going to be implied, right? Both the left side and the right side have to be positive because the square root of a number isn't going to be negative. It's going to be 0 or positive. So we know by default that y is going to be greater than or equal to 4. So now we're just dealing with y minus 4 equals the square root of x minus 1. I can add 4 to both sides. Y equals square root of x minus 1 plus 4. And then finally we put this in f inverse of x notation. Square root of x minus 1 plus 4. All right, so that's our inverse function. So we want to graph that as well. Let's go ahead and put that in our graphing calculator while we're over here. So square root of x minus 1, scoot out of there. And then we have plus 4. All right, and remember in our blue parabola that's on the graphing calculator, pretend like the left half isn't there, it's only that right half. And then that red function is the inverse function. So if I were to graph f inverse of x, then all I would need to do is switch the ordered pairs that we came up with before. So switch the x and y. So we'd have 1, 4, 2, 5, and 5, 6. So there's 1, 4, 2, 5, and then 5, 6. And that's my graph of f inverse of x. Okay, next to my graph of f of x. All right, so there's both f of x and f inverse of x with 3 points. Also, just a quick reminder that a function and its inverse are symmetric about that line y equals x, and you can see that in this case. All right, so going down to C and D, C says use interval notation to give the domain and range of f of x. So f of x is our original function. Remember the domain was that x is greater than or equal to 4. So translating that into interval notation, the domain is from 4 to positive infinity. And I can see that on my graph. 4 is the smallest x value, and then x can get bigger from there. All right, for the range of f of x, looking at that gray function, for the range of f of x, I'm going from positive 1 up to infinity. So for the range, the lowest y value is 1, and then y increases from there. So that's the range of my gray f of x function. Okay. Now, part D says use interval notation to give the domain and range of f inverse of x. So now looking at my purple function, looking at my x values, the domain goes from 1 to infinity. So for my purple function, the farthest to the left I go on the graph on my x-axis is 1, or x can increase from there. So that's my domain from 1 to infinity. And then for my range, the lowest that y equals is 4, and then I increase from there. So the lowest y value on my purple inverse function is 4, and then I increase from there to infinity. So from 4 to infinity. All right, and I want to remind you guys that, remember that we are switching x and y whenever we go from an inverse back and forth to its original function. And that includes switching the range and domain. So the range of the original function is the same as the domain of the inverse. The domain of the original is the same as the range of the inverse, and that will always be true.